All right. So hello, thank you for being with us tonight. My name is Kim Swan, and I'm the Water Resource Coordinator for the Clackamas River Water Providers. I'm going to kick off our workshop tonight. Before that, it looks like most of you are muted. So if you can continue to be muted so we don't hear lots of background noise, that would be appreciated. We have a series of presentations tonight, and we decided, since we're in this virtual format, that the easiest way to be able to answer questions is at the end of each presentation. So as we conclude presentations, you can either at the bottom of your screen, you can put your questions in the chat function, or you can use the reaction buttons and raise your hand. And Lisa Kilders, raise your hand, from the Sloan Conservation District, she will be moderating the questions in the chat and as people raise their hands. So, and then if we have time at the very end, after all the presentations, if there's some additional questions, we will have time to answer those. If not, if you put your questions in the chat, we will make sure we get those answered and those back to you. So I think with that, I'm gonna kick us off here. All right, so hopefully you guys should all be able to see my screen here. Okay, so the purpose of this workshop is to basically provide an overview of what septic systems are, how they work, how to properly operate and maintain them, and how to identify signs of failure. So Brandon Lamp from Aqua Resource Design Consulting will be talking in that part about those topics for our presentation. Heather Nilsson from Clackamas County, a soil scientist, will be talking about relevant codes and permits for septic systems in Clackamas County. And then we're going to conclude the workshop talking about some of the technical and funding assistance available to septic system owners, both through the Clackamas River Water Providers, and Ian Rains will be talking about assistance available through the Sloan Conservation District. So to tell you just a brief introduction of who we are, I represent all the cities and water districts that get their drinking water out of the Clackamas River. This is kind of shows you who those organizations are. Hopefully this gives you a spatial idea of where those citizens who drink that water live. You'll see the Clackamas River as it comes into the Willamette. Most of our customers and citizens actually aren't inside the Clackamas River watershed. And as you can see from this map, some of them are actually on the other side of the Willamette River. Combined, however, we provide drinking water to over 300,000 people in Clackamas and Washington County. And with the exception of Estacada, which is higher up in the watershed, our drinking water intakes and treatment plants are all in the lower couple miles of the river. And so as water providers, we are looking upriver at what potential threats and what kind of water quality degradation could happen, and looking at ways to work with partners to help keep the river as clean as possible. So this just kind of gives you a scale. You can see here, this is the watershed boundary. So our watershed is very large. It's 940 square miles. Most of it is actually national forest, kind of everything above Estacada. The middle of the watershed, however, has lots of agricultural uses, as well as people living in the watershed. So a lot going on. So as water providers, why do we care and what are we trying to protect? Well, it's that drinking water for those over 300,000 people. We also are concerned and working with partners to protect groundwater. Many people who aren't hooked up to city water systems have their own wells. So Protecting properly functioning septic systems also makes sure that their water source is protected. And then, of course, there's environmental health issues. The Clackamas River is not only a drinking water source, a source of water for farms and for recreation, but it is also home to pretty much all of the listed and endangered salmon species. So impacts from not properly functioning septic systems and those water quality impacts can also endanger fish and other wildlife. So we know from EPA and other nationwide studies that 10 to 20% of septic systems fail at some point. That means they're either directly running off that treated waste into surface water sources, or it's infiltrating and contaminating groundwater, which at some point will connect back to our river or tributaries. So some of the contaminants we're worried about are pathogens, nitrates, organic matter, ammonium, nitrogen, phosphates, synthetic organics, metals, personal care products, and pharmaceuticals that are leached through systems and could potentially get into our waterways. So in between 2012 and 2014, the Clackamas River water providers conducted a number of GIS risk analysis to look at the different land uses in the watershed above our drinking water intakes to get a better sense of what was happening in the watershed and what those threats are and how we could work with partners to address the potential water quality impacts. And so septic systems was one of those risk analysis that we looked at. And when we did this analysis, we looked at a number of different risk factors. And so those included septic system clustering, septic system age, how many septic systems there were per 2 acres, and then their proximity to either the main stem of the Clackamas or to one of the tributaries that drains the Clackamas. By looking at all those risk factors together, it gave us maps that you see here on the right, which is the cumulative septic system risk. So in the different colors show the high, medium, or low risk. So in doing this analysis, we identified over 9,000 potential septic systems above our intakes in the Clackamas River watershed. 4,500 were ranked low or very low, 3,500 were in that moderate range, and over 1,000 were ranked as high. So those were because they were a combination of all those risk factors overlapping in that previous slide. So, and about 76% of them were aged to be 30 years or older. So older systems have unless they've been properly maintained, which Brandon's going to talk a lot about, have a much higher risk of failing. So, and this is kind of shows the watershed, and what this did is it kind of showed us areas where those higher risk systems were. So we have the bottom of the basin here, and we have an area around Estacada. But as you can see from all the colors on this map, there are lots of septic systems all over, and especially in this lower part of the watershed, which is more directly close to these stars or our drinking water intakes. So we are working with partners in the basin to help address this problem. So by offering workshops like this of how septic system owners can take care of their systems before they become water quality problems. In 2012, we worked with the county and the local police departments to install drug take-back boxes around the county. Our wastewater treatment plants and our water systems are not able or don't have the capacity to treat for prescription and pharmaceuticals very well. So we really do not want people flushing these down toilets. They should be returned to boxes such as this, and those are the locations where you can find them in the county, so they don't that doesn't become an issue for us downriver that we're trying to figure out how to deal with. And then we've developed a bunch of educational materials. So if you signed up for this workshop, you should have gotten links to all of these documents. We've created a variety of brochures and the homeowner's guide over the years. If you didn't get the links to these, you can go to our website listed at the top, and you can download all of this information from there. So with that, I'm going to stop sharing my screen, and I am going to pass it on to Brandon to talk about what a septic system is and how they work.
Thanks, Kim. Everybody hear me okay?
Yep.
Good. So yeah, I think that we've done a number of these over the years, last several years. This is the first one we've done virtually, so kind of new territory for us, but it's always a good experience to go out and talk to the public about their septic systems, and you know, it's usually pretty good interaction. We're going to do it a little differently tonight. So if you do have questions or comments or, you know, any personal experiences or anything that you'd like to share and talk about, we will have a little bit of time at the end to do that. So questions in the chat, or you can raise your hand and toward the end of the presentation, and Lisa will moderate that for us. So I'm going to go ahead and share my screen, Kim. How's that look?
Looks good.
Good. Okay. So my name is Brandon Lamp. I'm a registered environmental health specialist, registered with the state of Oregon. I've been working on what we call on-site wastewater treatment systems or septic systems for a little over 20 years. Most of my work is in system design and consulting, and I primarily work on larger facilities than single family residences. But you know, I stay involved with some of those as well, particularly on difficult sites and situations and repairs and that sort of thing. But a lot of my work at this point is on state issued permits for larger commercial systems. But anyway, so we're going to talk today about septic systems. This is a real brief, well, not brief, but basic overview of septic systems and how they function and what we expect them to do, and potentially how to deal with issues or head off issues as they come up. So I presume everybody in here has a septic system, or is on a septic system, but whether you are or you aren't, hopefully we'll all learn a little bit something about them today. So septic systems go back a very long time, back to the Minoans and the Cretians, and they had rudimentary septic systems, you know, thousands and thousands of years ago. The definition of septic, as probably most of you know, is often associated with getting an infection. When a person goes septic or an animal goes septic, it's not a good thing. That means they've got an infection, and we're having to deal with that, typically by pumping somebody full of antibiotics or some other treatment. And so the idea that a septic system is an infection is not entirely correct, but it is fairly accurate in that, yes, septic systems do have a good amount of bacteria, but in their case, the infection is actually a good thing, as it starts the treatment process in a septic system, and actually takes the wastewater and knocks it down to, you know, pretty close to drinking water, or drinking water in some cases. So what does a septic system do? First thing it does is it treats the sewage that you put into it. And we're going to talk a little bit about how that works and what levels of treatment there are and that sort of thing. And then once it's been treated to whatever extent you need it to be treated, then we get rid of it. Where does it go? And the nature of a septic system is it goes into the soil, into the ground, and not like a municipal treatment plant. It doesn't go into a river or a stream or something to that effect. We generally put it into the soil. And in fact, the soil is not just a vehicle to get rid of the effluent or the wastewater, it's also part of the treatment process. And then finally, what does it do? Well, it recycles that water that we use in our homes and businesses. And we put it, since we're not putting it into the nearby waterway, it gets recycled into the groundwater, which sounds a little awful, but it's actually a good thing and a very efficient thing to do. So is the term septic system accurate? It is, but in this case, like I said, the infection is actually a good thing for the most part. So here's a diagram of what a fairly conventional septic system might look like. And you can see here's a dwelling. They're generating sewage in the home like we all do. And that sewage goes out, and instead of going into a municipal sewer, it goes into a septic tank. And there are a lot of different shapes, sizes, and types of septic tanks. And we'll talk a little bit about that in a while. And then it'll go, if it's a standard conventional system, it'll go from that septic tank typically into a subsurface disposal system or a drain field, where it's input to that unit, and then it's able to percolate out into the surrounding soil. And then as it travels through the soil, it actually gets further treatment, physical, mechanical, and biological treatment in the soil. So the idea is, and it's not just an idea, in practice, we've learned that it works, is it purifies that effluent or that wastewater. And then eventually the intent is it makes its way back into the water table or the groundwater. And lo and behold, as terrifying as it sounds, we eventually end up recycling that water and potentially use it again. So here's another diagram of basically the same thing we just looked at. Here house, it's got a pipe coming out going into a septic tank. Here's the well over here dipping down into that aquifer, and then here from the septic tank it goes out into a drain field system. And I don't know if any of you have any experience with septic systems or physics or construction or plumbing or anything like that. There's something wrong with this drain field arrangement, and anybody that can point it out at the end of the presentation gets extra points. This is set up to not work well. So what is sewage? Sewage is, well, we all know what sewage is. Basically, we tend to break it down into two types, black water and gray water. And black water is pretty straightforward. It's basically any of the wastewater that comes out of your toilet. It's restroom waste. Sometimes we'll consider bathroom sinks and whatnot to be part of the black water stream, but mostly it's toilet waste. And the rest of it, everything else, kitchen, laundry, showering, etc., is considered gray water. And one of the big misconceptions often is that septic systems or sewage that you generate is mostly black water. In fact, the opposite is true. As we're going to see in a few minutes here, typically only about 20% or so of your sewage that you generate in your home comes from the toilet. Most of it is everything else. So then your household generates sewage. Guess how much? This is kind of hard for some folks to swallow, but believe it or not, generally individuals will generate between 50 and 90 gallons per person per day. And you're thinking, there's no way. I don't flush the toilet that often. It's the era of COVID. I don't even take a shower every day. There's no way I'm doing that. But it's the truth. And my wife and I've tracked our sewage flow, or excuse me, our water use rather. And we're pretty conservative about our water use for the most part, inside the home anyway. There's some irrigation outside, but we're usually around 40 to 45 gallons per person. So we're actually below this range. This is a more typical range, and we see often some households will use more water than that per person. But it's a real number, folks, and we really do, between showering and laundry and whatever else we do, kitchen, food preparation, per person, that's how much water we tend to use. So the question here, this is usually the interactive part of the presentation, but the question here is, what is the most common reason that a septic system might fail? So there are a million reasons why a septic system, or anything else for that matter, might exhibit problems or fail. I will tell you that as far as septic systems are concerned, the most common reason is too much water going into that system, and our expecting it to process it. That system was designed for a certain capacity, and if we ask it to exceed that capacity, it's not going to go well. It's similar to if you buy, say, I can't think of a good example, but a small Hyundai car, and you try to drive it 175 miles per hour, it's probably not going to go well. So this is an older pie chart that breaks down that 50 to 90 gallons per day, and how it in a household, that is, and how it adds up. This has changed a lot over time, especially in the last, say, 20 years or so. But if you can see it down here, it says the total GPCD, which is gallons per capita per day, or per person per day. The EPA decided in 1999 that was, well, they didn't decide it, they studied it and found that it was 69.3 gallons per person, which is, as you can tell, right in the middle of that range. So where does that water come from? Well, we'll start here. The misconception of the toilet. Back in 1999, they estimated 26.7%. We know now that in more recent times, that percentage of the total flow has gone down. And the reason for that is primarily low flow toilets. There are code requirements that came through that required fewer gallons per flush. And then there are some ultra low flow toilets that people will put in now that use even less water, or the dual flush toilets, what I call the number 1 and number 2 toilets, that use, most of the time they use a pretty small amount per flush. So that number now is probably closer to about 20%. And then showering and bathing, that's about 18% more or less of our total water use per day. So it's basically equivalent to the toilet use. I think that percentage has gone up. And why do I think that percentage has gone up? I think it's gone up because a lot of new construction homes, especially affluent homes, have more than one shower head. And back in 1995, most of us didn't have more than one shower head, and some of us do now. I've worked on projects where a single family home had as many as 6 shower heads in one shower, and it's cumulative. So in some cases, that percentage might be really high, depending on how they use their shower. Clothes washer, 21.7%. I think that number has gone down, and that's due to the advent of the current high efficiency machines. They use older machines. The traditional top loaders would use anywhere between 20 and 90 gallons per load. And new machines now will often use 5 or 7 gallons per load, or sometimes even less. It's a huge difference. Dishwashers, same thing. What's interesting about dishwashers is dishwashers never used very much water. Even the older ones that were much less efficient, they would use typically 10 or maybe 15 gallons per day, or per load, which is not really that much when you think about it. But a modern high efficiency dishwasher, I just bought a dishwasher about 6 months ago, and it uses 3 to 4 gallons per load, which is nothing. I mean, you can burn through 3 to 4 gallons hand washing one pot. So this is your encouragement and your permission to use your dishwasher as much as you can, because it's actually a good thing. It frankly uses less energy, it uses less hot water, and it uses a heck of a lot less water. And boy, it's a lot easier for you, the dishwasher, to put things in there and take them back out rather than scrubbing away. So interesting thing about dishwashers, don't be afraid to use them. Faucets, 15.7%, probably around the same today. And then leaks and other. So here's the thing about leaks. Leaks happen. Drippy faucets, toilets running, that kind of thing. Leaks are accounted for when somebody designs a municipal sewer system. With on-site wastewater systems, that number really needs to be 0. Because again, our system has a capacity, and we haven't designed it to allow for really any leaks whatsoever. I mean, a drippy sink that burns, a half gallon every 9 hours or something like that, whatever, no big deal. But for the most part, our systems are not set up to handle any significant leakage. So this is a 2013 toilet, and it's a low flow. So I believe it's 1.6 gallons per flush. But in this picture, I'm wondering how much water it's using. And you're thinking, what do you mean? Well, I just went through this within the last month with that very toilet. We got a kind of a high water bill, and this toilet, honestly, you could not hear or see any water running at all, ever. And what I did is I did some testing on it, and I found out that it was intermittently leaking, and you would never know. And so the short answer to that question is, we've been able to study this in the field. We've had a single toilet, and this is going to blow your mind potentially, a single toilet that you can't hear or see running at all ever can generate as much as 400 gallons per day. And that's one toilet. And bear in mind, most on-site systems in Oregon for residences are sized at 450 gallons per day. So you've got one toilet potentially taxing your system with 100% of what it's intended to receive, plus everything else that you're normally doing. So here's the other example. This is a 1942 American Plumbing Company toilet. And you're wondering, well, I'm wondering how much water that uses. So a normal flush for that toilet, I'm not going to lie, it's probably 10 gallons. It might be more than that, but I'll tell you, it works really well. But the point of this is, when you have a toilet, whether it's an old toilet or a new toilet, doesn't really matter. And you can hear it running, or occasionally it will cycle and you'll hear it. Or if it's running stuck wide open, kind of like that video just showed, we've in the field found that a single toilet can generate as much as 2,600 gallons per day. One toilet running wide open is going to generate that much water in a day, or it's not going to generate it, it's going to use it. I've heard stories about even more than that, like 3,500 gallons, and I suppose that's entirely possible. But anyway, so if you have a toilet that you can see or hear leaking, believe it or not, that's a critical emergency, and you need to shut it off and get it fixed right away if you're on a septic system, or even if you're not. In the case of the silent toilet, what do you do about that? Well, I personally dye test my toilets at least once a year, more so if I think something's going on. And it's really simple. All you have to do is flush the toilet, let it finish filling up, leave it alone for a couple of minutes, take the lid off the tank and add a few drops of food coloring, your color of your choice. Wait about 5 or 10 minutes. Don't flush the toilet, don't do anything, don't touch it. Wait 5 or 10 minutes, or even longer if you can, maybe wait an hour. Go back and look in the bowl. If you see any color in that bowl, it's leaking, and that water is going out to your septic system, period. And you're going to want to fix it because you don't know how much. Is it pretty minor and it's that 5-10 gallons a day kind of situation, or is it actually pushing 400 gallons per day out into your system and creating that damp or squishy spot in your yard? First thing to look at with any kind of a problem with the septic system, honestly, is toilets. So this is a diagram. This is a under sink reverse osmosis water treatment unit. And we had one of these put in our house about 7 years ago, and I didn't realize it at the time, but again, because I'm a nerd, I looked at our water bill, and our water use went up a little bit and didn't know why. what these systems are great, but what they don't tell you, or at least don't overtly tell you, is they use water in order to treat the water. So for every gallon that you get out of that system, you actually have to use 3 to 8 or 9 gallons to generate that 1 gallon that you can drink. And the rest of it goes right down the drain. So just be aware of that. I'm not saying you shouldn't use it, but know what it's doing and know how much more water you're putting down the drain that you never knew you were putting down the drain. My understanding is now there are some of these that have a different treatment approach, and they actually don't waste any water, but they do use energy. So you need to be able to plug it in somewhere. I don't pretend to understand how that all works, but just FYI, if you have one of these, be aware that it's using a lot of water to treat the water that you drink. So what are we worried about with sewage and septic systems? So basically, there are some things in sewage that we don't want any part of. Pathogens, we've learned a lot about those in the last year plus. Bacteria and viruses. Those are harmful potentially to we humans as well as our pets and the environment and animals and whatnot. And then nutrients are also omnipresent in sewage. The ones that we're particularly concerned about are nitrogen and phosphorus. Both of those are things that can limit water quality and cause algal blooms in streams and potentially be harmful to fish, et cetera, et cetera. And then finally, anything that you put down a drain, whether it should be going down the drain or not, it becomes part of that calculation. So things like chemicals, toxics. I just had a conversation with a DEQ person today about heavy metals. And just bear in mind that anything you put down a drain becomes part of that waste stream. It used to be we had issues when people used to develop photos in their house. This was a long time ago, but those chemicals were so toxic to septic systems, they would literally kill the biology in the septic tank. We still run into that issue with some things like, overuse of disinfecting cleaning products and things like chemotherapy drugs. They can do the same thing. And then one other thing to touch on that Kim mentioned with regard to the prescription drugs or any drugs for that matter, and the need for the drug take-back programs is drugs. Most pharmaceuticals, when we ingest them, our body uses very little of what we've actually ingested. In some cases, your body will only actually absorb maybe about 3% of that medication, and the rest of it goes right through you. So we can't change that, but just keep it in mind that that's how a lot of this stuff works. So with regard to septic systems, what are we concerned about? Well, we kind of already talked about public health and environmental health. What are some of the reasons that people are put off by septic systems? One is the perception of pollution, or the fact that you've got this tank full of, let's face it, raw sewage in your backyard. And then also, it's often seen as a hurdle for developing land. There's no question that you need a bigger piece of property to have a septic system sited on it than if you had the ability to connect to a public sewer system. So what are some of the good things about septic systems as far as development and that sort of thing are concerned? One is they're decentralized, and to most of us that doesn't make any difference, but the good news is that rather than putting sewage into a community system that might have issues, we hear regularly about sewer overflows that occur, and maybe the city of Portland or something in one day or a couple hours dumps 50,000 gallons of raw sewage into the Willamette River. This happens. With a septic system, that can't really happen. You can have issues with that system failing for sure, but it's maybe that 450 gallons per day at the most. and for the typically you're containing that problem to your property, or maybe a neighbor or two, rather than an ecosystem level kind of event. The other reality is they are much more cost effective, pretty much universally, than connecting to a sewer system. And we won't go into a lot of that, but sewer systems are extremely expensive to develop. Most of them come along with what they call system development charges, that when you develop a property, you're expected to pay a large chunk of money in order to just get access to that sewer system. Typically, it's in the tens of thousands of dollars or more. The other is environmental friendliness. Again, we're potentially avoiding that catastrophic level discharge, but also we're doing, as we talked about earlier, we're recharging the groundwater, et cetera. So we won't spend a lot of time on this, but you can see that the example on the left shows presumably a bunch of single family dwellings and a sewage treatment plant, and pretty much all of these are connected to that plant. Again, sewers are really expensive to construct, and if we moved more toward a model that's on the right here, where you've got dense clusters of dwellings and you have sewage treatment plants serving those, that can make a lot of sense. But maybe these folks out here, where you would have to otherwise run a pipe for miles to serve them, maybe they're better off on septic systems, both financially and just on a practical level. So why are you on a septic system? Well, the reality is 100 years ago, people thought the world was going to be sewered, and we found out that that's just not the case. Again, for cost reasons or practicality or difficulty constructing, demand, etc. So really, the residences in the United States, about 25% are served by septic systems. And in Oregon, that percentage is even higher. We estimate it's around 30%. So almost 1 out of 3 people in this state does not have a sewer connection, which is quite a bit. Can I get rid of my septic system and voluntary opt-in for sewer service? Probably not. There aren't a lot of these sort of overlap areas where, maybe the lots were on septic originally and then sewer came down the street. In those cases, sometimes there's that ability to connect if you wanted to, but again, it's going to cost you. Okay, so here are the nuts and bolts of septic systems. This is a typical septic tank. On this end, on the left side, that's where the pipe would come from the residence, or the sewer line would come from the residence. Sewage comes into the tank here. And what happens is what we call mechanical separation. So the heavier materials, heavier solids will sink to the bottom. The lighter solids of fats, oils, grease, paper, that kind of thing will rise to the top. And then, so what happens is we have this relatively clear zone in the middle, and that's the liquid that we're attempting to capture and send on out to the next step in the process. So what does a septic tank do? It mechanically separates solids, like we talked about. It slows the flow down as it goes through and out the outlet pipe. It provides anaerobic treatment of sewage. A septic tank is considered to be anaerobic because we don't input any oxygen to it to speak of. It's not entirely anaerobic, but there are some bacteria that really do well and start to break down that wastewater via anaerobic treatment. And there are many different ways to measure waste strength and different constituents in sewage that we're concerned about. But just having that box in the ground, completely passive, will generally reduce waste strength by 50 to 70%. And in some cases, and depending on the constituent we're targeting, sometimes they do even better than that, as much as 90%, depending on what we're concerned about. And then, of course, they're not hands-off. Over time, those solids will accumulate to the point where they're going to be detrimental to the system's performance, and you do have to have it pumped out. I know a lot of the older systems were installed without access lids, and people weren't really thinking about maintenance necessarily until there was a problem. Now we have to have access lids on systems, and it really makes sense to maintain your septic tank to the extent that you can, because it protects the components downstream, the drain field, and some other things that we're going to be looking at here in a minute. So what do septic tanks do that a lot of people think they can? What can't septic tanks do that a lot of people think they can? So a lot of people that are on septic systems, well, first of all, a lot of folks that are on a septic system don't even know they're on a septic system. But if they do, they don't really have an idea what this tank does. A lot of people think it's a 1,000-gallon tank. Well, that's never going to fill up. So it's just this tank in the ground. And when it fills up, I have to have it pumped out. It's like, well, no, it's always full. It's just a question of what it's full of. But one thing a septic tank can't do, the only thing it can't do anyway, is it can't get the water. It can't make the water go away. So here's a quick example of a tank. If you, for example, you have to lift the effluent, the treated wastewater to another point, like if your drain field is higher than where the tank sits, you would have to put in a pump system. And this is one example of that. Basically, this compartment of the tank acts like the septic tank. And then the second compartment receives that relatively clear liquid and is pumped out through a pumping system. Here's a picture of a septic tank that's been installed, and you can see the sewer line coming from the building, and then there are those access risers and lids to grade that we just talked about, and then the outlet pipe. So this is a picture of a drain field. This is the component where the sewage ends up, and we're going to talk about them in a little bit in a minute. Sometimes they're pretty apparent where they are. You can see this is an area that hasn't been irrigated much, and you can see where it is irrigated subsurface. The grass is always greener, not usually over the septic tank, but over the drain field. Sometimes the opposite happens. If a system is particularly heavily loaded, it can actually cause grass to yellow. And I think that's because, it overwaters it, and also nitrogen and other constituents can cause grass to yellow, is my understanding. So here's a fairly typical cross section of a drain field and what that looks like. And it's a pretty simple technology. Basically, you dig a trench and you put some gravel in the bottom and a perforated pipe that wastewater can flow out of. And then you put some material here to keep this backfill or the native soil from falling down and getting into the gravel and the pipe and causing problems. So this is a pretty conventional system. In Oregon, most of our drain fields are 18 to 36 inches deep, and the depth depends on things like slope and the type of soil you have and whatnot. But this is a cross section of what a drain field trench looks like. So this diagram, in some cases, your system will incorporate a secondary treatment component. And there are different shapes and sizes of those, and different reasons for having them. One thing about secondary treatment is sometimes you have soil or water table conditions that require it, that code requires you have secondary treatment. One of the benefits of secondary treatment is it allows you to install a much smaller drain field, typically about 1/3 of the size of a typical conventional drain field. And that's due to the quality of effluent that leaves the system. So this example, septic tank, it's going to pump into this. In this case, this is a sand filter system. We don't see a ton of sand filters on single family residences anymore, and there's some reason for that. But that's a treatment unit. It doesn't get rid of the water, it treats it to a point pretty close to drinking water quality. And then in this case, it pumps out to a drain field, a reduced size drain field from there. We won't go into this much, but here's some cross sections of what sand filters look like. Sometimes they have an internal pump, sometimes they can gravity flow out depending on slope and elevation differences, etc. Here's a little closer view of it. You've got this thing dug into the ground, typically, some gravel and a collection pipe here. This is 24 inches of sand, and that sand does a pretty amazing job of treatment. As I mentioned before, it takes septic tank effluent and turns it into something that's pretty darn close to drinking water. There are still some pathogens in it, and there's still some nitrogen in it, but for the most part, it's pretty clean stuff. We're going to skip this. So that's when a sand filter goes bad. The drain field's probably fine because the problem is not at the drain field necessarily, it's at the sand filter. That's largely due to the issues going on with that, largely due to too much water use, like we mentioned, is the #1 killer, and potentially also lack of maintenance. So I mentioned the water quality. This example on the right is septic tank effluent. That's that relatively clear liquid that comes out the end of a septic tank. The example on the left is sand filter effluent. Sand filter effluent, typically, if everything's operating as intended, I could probably serve you a glass of it and you wouldn't turn it down. It's that clean. It's cleaner than most of our river or the water in our local streams. So instead of sand filters, typically now folks, as of 2005, will install a proprietary treatment unit. And there are a lot of different reasons for that. Most is practicality and cost and simplicity of construction. So now this is a textile filter that basically does the exact same thing as a sand filter as far as what comes out the tailpipe, if you will. Here's an aerobic treatment that also does a similar, it's a different treatment process, but the end result is similar. So you're on a septic system. Does your septic system work? Well, everybody, kind of like people not necessarily knowing how a septic tank works, people have different definitions of what a septic system, what it means when a septic system works. So there's the first example where it's a hands-off approach and we've never had a problem and sewage has never come into the house and never showed up in the yard, so we're happy. So I refer to that scenario as the ticking time bomb. Nothing lasts forever, and it really doesn't last forever if you don't maintain it. The second definition is the system actually works as intended, and you're providing treatment, you're dispersing it responsibly into the soil, you're maintaining the system, you're not polluting. Groundwater is a water of the state, and it's something that you can pollute and never even know about it if your system's not functioning properly. Here's a definition of waters of the state that includes that underground waters clause. So you can actually be in violation for discharging partially treated effluent into groundwater, not just the local stream or what have you. So hopefully nobody in here has ever experienced anything looking like this in their yard, but if you have, this is, or if you haven't, this is what a failing drain field looks like. Typically you've got some area of ponding. It often has a odor associated with it. You'll see some algae growth pretty typically. Not a good thing, and certainly a public health hazard and a hazard for pets and whoever else might be in the area and using that area. So as a property owner, as a homeowner, what could you do to operate your system correctly? Like I mentioned before, water conservation. Water is the #1 killer of septic systems, or too much water rather. So conserving water is a good thing to consider doing. And then the other thing, like we talked about, especially toilets, is to repair any and all leaks in toilets and sinks. And so we're not putting too much water into the septic system that way. And again, that's because the septic tank or the septic system The one thing it can't do is it can't make water disappear. It has to go somewhere. So as a property owner, what can I do to operate my system? In addition to the amount of water, you want to be cognizant of what you're putting down the drain. Basically what I call the straight face test. If you wonder about it and you wonder whether it should go down the drain, the answer is it probably shouldn't. You know, any kind of excessive chemicals or motor oil or antifreeze or, you know, 5 coffee cans worth of bacon grease or what have you, these are all things that you shouldn't put down the drain. And you know, if you have to think about it, you probably don't, and you probably shouldn't. And if there's a way to dispose of it in some other way, you should certainly consider doing that. So the drain field areas are pretty sensitive in some cases. And one of the things we see a lot of is people will build over their drain field or create a driveway over their drain field or allow cattle over their drain field or dig soil off of the top of their drain field or fill soil over the top of their drain field. And these are all not good. Sometimes it will create some pretty overt damage that will cause problems right away. Sometimes it takes years. Like for example, if you fill an area, it may compact the native soil, which will cause problems with permeability going forward that may not show up right away. The other thing is the drain field is designed to receive so much water, as you know, so don't use too much water. There's nothing wrong with watering your lawn or whatever you have over a drain field, but try not to inundate it. So septic tank additives are something that people often ask about at these presentations and otherwise. And should I use them? They think it's, you know, some of the marketing and whatnot tells us that, well, we should really be putting things into our septic system to keep it healthy. And the fact of the matter is, there's nothing better at keeping a septic system healthy than doing the things we just talked about. Everything that your septic system needs to function properly comes from us, comes from our waste. All the biology we need is there. We don't need to add any. We certainly don't need to add any chemicals or other treatments. Additives are, long story short, a lot of them are just marketing. People trying to sell a product that a lot of us don't need. And in some cases, they've actually caused problems. So this is kind of opinion. There are some maintenance requirements for septic systems in Oregon, but they generally only apply to systems that are a little bit more complex or involve a treatment unit because they're more sensitive and have more moving parts. But in my opinion, any standard system with a septic tank drain field should be inspected about every 3 years. That doesn't mean you necessarily need to have it pumped every 3 years. In fact, pumping of tank too frequently is not recommended because it disrupts the biological process to some extent. But it should be looked at just to make sure that everything is doing what it's supposed to be. Pump systems have moving parts, electronics, etc. They should be looked at, in my estimation, once a year, or maybe every 2 years, but regularly. Often in Oregon, they have the filter component too, and if you don't clean the filter, you're going to experience problems there too. So about once a year to have those systems looked at, even if they're not technically required via a maintenance contract or something like that. And then any system, like I mentioned, that uses a treatment unit is going to be required to have a maintenance contract, and that system is going to have to be looked at least annually. So here are some of the pitfalls of not maintaining a septic tank. This is a 2-compartment tank, which we don't see a ton of in Oregon, but it paints a good example. Here we've got a pretty healthy tank that's been pumped when it needs to be. The clear zone is pretty open, and we're getting relatively clear material out of that tank. This one, you can see the sludge has built up to a level that is basically, we have no capacity left in that tank. It's all the void space that we had is now gone and taken up by solids. So what happens is, or what can happen, and this can happen either with the sludge or the scum layer, is that stuff will start to get taken up into these baffles, and you'll actually pass solids out into the drain field with the tank, and your insurance policy as far as protecting your drain field has just been voided. Here's another potential issue: is the drain field diagram we looked at earlier looked something like this. All drain fields, well, not all, most drain fields develop what we call a biomat, which is a layer of bacteria at the bottom. And that bacteria's job is, what it's there for is it eats the nutrients in the sewage as it goes through. And the biomat sometimes will develop up the side of the trench to some extent too. It's a good thing, but there's always the potential for too much of a good thing. And once it gets so thick, it can actually preclude flow from wastewater from getting out of that trench. For example, it could be completely dry over here and this trench could be full because the water can't get out as fast enough. It's being sent in there at a rate faster than the soil can, then it can get to the soil. And one of the reasons that biomat can get thick is due to a tank that's not been maintained properly. Another thing is too much water. If we create a anaerobic condition in this trench by too much water, whether it's water from the septic system or water, groundwater, it can cause that trench to fail as well. So this is a tank pumping interval chart. Take it with a real grain of salt. It doesn't really mean anything in reality because every household is different. People that use different volumes of water, people use different things, people have different things going down their drain, et cetera, et cetera. So what I would recommend is if you have 1,000-gallon tank and you've got, say, 3 or 4 people living in there, this chart says you shouldn't need to pump it, but every 3 or 4 years. That's probably fair. I mean, most of the time we're seeing a 2 to 5 year intervals on tanks in a fairly typical residential situation. But for example, if you have one person living in the house, you might not have to pump that tank, but every 10 years. And again, it's not necessarily a good thing to have it pumped more often. Okay, so the good definition of does my system work is dependent on 5 things. And unfortunately, it's no more than 5 in my estimation, but unfortunately, it's no fewer than 5. And all of these things have to come together for a septic system to work indefinitely. And it used to be that, well, it still is to some extent, some of the regulatory community and even some of the private sector folks believe that septic systems have an expiration date. And a lot of times people would say, well, they're good for 30 years and then that's it. Well, that's not true. I mean, septic systems, like I mentioned, will fail for a variety of reasons. But if we maintain them properly, they don't have to fail at all. But in order for that to happen, we've got to have all of these things. So go to work for us. So one, the system has to be sited properly. This is where in this case, Clackamas County comes in. They go out and they evaluate a site and the soil conditions, and they make a determination whether a drain field will have a chance of success in those conditions, and they'll prescribe the type of system that would be required in order for that system to be able to function adequately and efficiently and in an environmentally friendly fashion. To the design, the system, a lot of the residential systems in this state are designed by contractors, which is great. Most of them have good experience and do prudent designs. And so the system design has to be consistent with what the county came up with as far as their site evaluation. And it has to be designed in a manner where it can function adequately. Construction. So construction, obviously, when you build anything, you've got to build it right. Otherwise, it's potentially not going to work. Septic systems are no exception. And construction defects happen. Sometimes they show up as problems pretty quickly. Sometimes it can take years. The county or is typically involved with the inspection of the systems as they go in. But even in the county's case, they aren't able to always see everything. Maybe something got built and covered or something like that. And, the inspection is a very important part of the process, but there's no way to look at absolutely everything during an installation. Operation. So this is the part that you as the homeowner do have a say in. Basically, we talked about not putting in too much water. We talked about the straight face test as far as what you can put down the drain. This is entirely on you. Again, we can't make the Hyundai go 175 miles per hour. So we have to treat it and operate it within its limitations. And then finally, we talked about maintenance. Every system requires maintenance, period. No question. It's just a question of to what extent and how much. If you don't maintain a system, it will fail. It's just a question as far as when. So that's the end of my presentation. Basically, if you have all those 5 things come into place, your system can last indefinitely. There is no expiration date, or at least there doesn't have to be. Thank you.
Great. Thank you so much, Brandon. So if anyone has questions for us, you can either use the raise your hand function, or you can type questions into the chat function, and Lisa will help moderate those questions for Brandon.
Oh, we have one question. Claire Clock, what's your question this evening? Claire, you have to unmute yourself. Claire, unmute.
Oh, there we go. Okay.
Good.
Oh, there we are. Okay. Brandon, you mentioned that about the reverse osmosis system, and this is a sort of technical question. You say it takes a lot of water. I know that Tri-Cities, the actual sewer plant, uses a reverse osmosis. Does it take them a lot of water? I know it probably takes energy, but are they in the same boat when like in a city water system?
With regard to municipal sewage treatment, or is it water treatment or sewage treatment?
Okay.
So are they treating potable water or?
Well, it goes to potable. No, it's the Tri-Cities sewer plant treats sewage and breaks it down and sends the solids off to fertilizer, but it breaks it down to potable type of water. And in fact, when they opened it up, they had bottles out there that were potable, and they're cleaner than a lot of systems because they eliminated the heavy metals and everything else. So I'm just wondering about that.
I would presume it's a similar situation to the systems that are available for under your sink. You probably can either consume a lot of clean water in the process, or you can consume energy in the process, or maybe a combination of the two.
Right. That I just you'd have to check with the operators there at Tri-Cities. And
yeah, do you know if they might use a membrane reactor?
That's right, they do.
Yeah,
that's part of it.
And they're an incredible technology, and they do an incredible job. I know that they are energy intensive. They use a lot of energy.
Right. And just a quick question, Lisa, another question. And Brandon, you showed the regular regular drain field with just a regular pipe through aggregate. What about the half tunnels that I've seen in some of the designs? Have those lost favor, or are they still used?
No, they're absolutely used, and I didn't include them in here because we try to keep things fairly basic. But yeah, absolutely, and I think Heather can probably comment on this. Most of the drain fields that are installed today utilize some kind of alternative technology. There's one that incorporates a gravel substitute that's made out of polystyrene peanuts. that has a pipe down the middle, and then the gravelous chamber is another system that's basically just a, like you said, a dome that goes in instead of gravel in a pipe. And those are probably much more common than the gravel and pipe systems at this point. And the reasons for that are, one, they're much less intensive and labor intensive to materials and labor intensive to construct. And two, they're a lot easier to haul around. So it's, the other thing is the gravel that we use in drain fields and other systems. It's hard to find a good clean source in our area anyway. It's not that that doesn't exist, but it's difficult. And so a lot of installers have transitioned to the proprietary drain field products rather than conventional rock and pipe.
Yeah, I understand that you didn't cover it probably because it's new construction rather than what most people are finding in their systems now. So thank you.
Right. Sure.
Okay, any other questions? No? All right, Kim.
All
You're up.
right. So Brandon, can you?
Yep. I'm shutting it down.
All right, there we go. All right, our next speaker up is Heather Nielsen with Clackamas County. And she's gonna talk us about some of the permits and regulations that fall upon in the county's jurisdiction around septic systems. So take it away, Heather.
Thanks. All right. All right. So hopefully everybody can see that.
Yep.
All right. So I am Heather Nielsen. I am a geologist and I am a wastewater specialist. So Brandon was an REHS, and the other license that we see in our industry is wastewater specialist. So I'm the other one. I work for Clackamas County. We are a 6-person team, our little department. There are 2 permit technicians, so they would be the people answering or calling you back if you called us with questions. They would be the people that you would most likely talk to if you came in with questions. And then there are 2 soil scientists and 2 senior soil scientists. And if you have soil scientist in your job title, we do the site evaluation. So we come out and evaluate what a property might be, what kind of system would go on a property. We do the reviews of the permits, whether it's construction, whether it's a reconnection. And then if there's any kind of inspection on the property, we would be the ones to go out and do that. We are always reachable by phone and email. That phone number will take you just directly to a voicemail. We do monitor it multiple times a day, and usually you get a same day call back. If you call later in the afternoon, maybe the next day. Our current hours are Monday through Thursday, 9 to 2. That's when the permit lobby itself is open. We have been working whether in the office or remotely all through the pandemic. So we have not shut down, but the lobby hours are more limited. And we have greatly expanded our, I guess, e-permitting. You can email permits to the soils concerned email address with payment and take care of a lot more things digitally rather than having to come in. Those hours are definitely subject to change. I know that the county has talked about bringing more people back more of the time, and we haven't heard how that's going to affect when we are open to the public. So the website would always tell you, or you can always contact us with questions. So we are primarily an agent of the Department of Environmental Quality's on-site program, septic and on-site wastewater. So they make the rules, and in Clackamas County, we are the department that enforces and follows them and helps everybody make sure that we're adhering to those. And if you have questions about them, we are more than happy to answer, because they are rules, they are code, they are not the most straightforward things. So we definitely want to act as a resource for residents with any kind of questions that they have on how to comply, whether they're currently in compliance, whether their project is going to comply, all of those things. So we do a lot of records research. We have records on septic systems going back to the late 70s most of the time, and some older as well, but permitting really started in the late 70s, so that's when most of our records start. And then there are occasional things that may have not been scanned properly or lost over time, but most of the time we can find a record on a system for a house built after 77, 78-ish. We do site evaluations. So a site evaluation would be, I need to install a new system on my property, whether it's brand new construction or whether it's like a repair. So if we don't have good soil data on your property, we may need to do a site evaluation. And I will talk more about those in a bit. We issue permits, we inspect the installations from the permits that we issued. We review requests for authorization notices. An authorization notice is whether you are increasing flow. Flow is calculated based on bedroom number. So you can have a 4-bedroom house with 20 bathrooms. It's still going to count as a 4-bedroom house. You can have an 8-bedroom house with 2 bathrooms, and we're going to look at those 8 bedrooms. So that's increase in flow. There's also, if you are connecting to an existing system, you would need an authorization notice. So whether you're doing a replacement dwelling, or there was a system, I guess that's still a replacement dwelling. If there was a system and you're building a new house and going to disconnect the old house from it, that's an authorization notice. And then building permits require septic sign off. So if you are putting up a new ag building, we want to know that you are not putting that on top of your septic system, and you're meeting appropriate setbacks. So we'll review those building permits and we'll sign off on them. A lot of that coordination with other county and local departments happens behind the scenes now. It used to be you'd come into the lobby and you'd go around to each station, with a building permit and get people to sign off. Now it happens behind the scenes as we work a lot more remotely. And then we respond to complaints. So if your neighbor, if there's a puddle of water that is consistently seeping onto your property, with a septic odor, we do a lot of complaints from neighbors. We do a lot of just general complaints, like we've had a couple from utilities who have been digging and then accidentally find something that, there was a pipe that shouldn't have been going to that ditch, or all sorts of things. So we respond to complaints and try to keep everything as much to code as we can. So site evaluations, like I said, they're kind of the first step to figure out what kind of new system you're going to install, whether that's brand new or whether that's repairing. So that site evaluations were once upon a time called perk tests. We do not add water to the test pits that we look at. We are going to look at the soil profile, and this little graphic, it shows the grass and it shows where the roots are, and it shows getting into rockier layers. So we're going to look at all those layers and get an idea of what kind of soil it is, how well does it drain, does water hang out there more than it should to add a septic system in. So depending on what we find is going to determine what kind of system you can have. If this is new construction, there is a chance that your site evaluation may say this is not a good site for a septic system, and that would be denied, and you would not be able to put a system either in that location or on that property. We look at the test pits that we see, usually between 2 and 6 per site evaluation. And so sometimes they get dug in a place that may not be the best location, and we could go back out and dig, or more pits could be dug, and you could find a different area on a property. That doesn't always happen, but sometimes. And we look where those pits are dug. We don't often give, opinions on, oh, well, you should try over there, or like tell you where to start looking. So some of the things we look at are the type and texture. So is it really silty? Is it really sandy? Is it really clayey? Like I said, where the water hangs out, site topography. So is it at the bottom of a hill? Is it on the hill slope? What kind of surface water is around? And then historical use would be, has the site been logged? Is that it? Was the site logged? Is that why we're missing all the topsoil? Or has the site been filled or cut? All sorts of things that could impact how well a system would do. And you really want an area that has not been impacted by historical use for a septic system. So like I said, lots of sites can be approved. Some sites can't be approved. And so this has a list of some of the reasons. Our site evaluations, if we deny them, you can dig more pits on the same site evaluation within 90 days. And then you can also appeal to DEQ. They have agents that represent different parts of the state. And they would come out and basically look at the site evaluation that the county did, and then go out and look at the pits again. And sometimes they have different, come to different conclusions, or, look at different factors, and they can make that decision. But that's their level, and that's their decision. The county has to follow the rules, and DEQ can say whether they're going to follow the rules this time, or whether this particular site can have a variance and do something slightly different based on whatever conditions are out there. So construction permits. Grab a sip of water. So once the site evaluation has been completed, if you're getting an approval, it will tell you what kind of system. So is it a standard system, a tank, and a drain field? Does it need a sand filter or some alternative treatment technology, those proprietary products that Brandon was talking about? And then what depth of trench you would get. So a lot of your construction details come from that site evaluation. Excuse me. So there's the new construction permit, brand new system, brand new piece of property. Minor repairs, this is probably the most common permit we do, and that would be for a tank replacement. So once upon a time, they installed a lot of steel tanks, and in our climate, a lot of those steel tanks have since turned very much into Swiss cheese. And so either during a property transaction, or just because somebody realized that their tank was no longer viable, they're going to replace it. So we do a lot of minor repairs. Minor alteration We do a fair number of those because if you're adding like a tank at your shop, so you have your house system, tank and drain field, you can add a tank at a shop and that would be a minor alteration. And then major repairs and major alterations would be you have something already and it needs replacing. So whether you're a homeowner and since you've been home so much, you know, you've noticed that now there's a soft spot in your yard. Maybe you need a new drain field. Alternatives to that would be a major repair. A major alteration might be you're home a lot more and you've decided you want to shop, but the best location for the shop doesn't meet the setbacks to your drain field, so you need to move part of your drain field. So those are some of the reasons we see major alterations and kind of the difference between repair and alteration. So authorization notice, kind of touched on that a little bit. So reconnection, you are doing a replacement dwelling. Increasing flow, you are adding a bedroom. You are adding a guest house would be another. Guest houses get treated like bedrooms. Accessory dwelling units have really been popular, and there are some places in the county where you can do them. Planning and zoning kind of are more the gatekeepers with that one, but it would definitely be an increase in flow. And I will say that most systems that have already been designed and are in use will not take an accessory dwelling unit or ADU being added to that system, just because it's basically adding another house on top of your projected flows. And then also change in use. So whether you are adding a business to your property or whether you are going from residential to commercial, those are some of the changes of use that we see, in which case we want to look at the septic system before that change of use is approved to make sure that it's going to handle the change in use. And so the process is you would have a septic contractor come out and do an existing system evaluation report, ESER. It's an 8-page report on a DEQ form, and it basically looks at all the components of the system and says what condition they're in. So you have a septic tank. How big is that septic tank? Are all the components of it intact? Is it functioning as intended? And then part of that is a drawing of the property, so that we can get an idea of where things are. And sometimes they'll put a proposed building on there so we can see, you know, what the plan is. Authorization notices are often required for building permit sign off. Occasionally construction permits if it's a brand new building. So we do a lot of authorization notices and construction permits. We also do existing system verifications. If we do not have an as-built drawing from an old permit from when your system went in, we'll ask for an existing system verification, which is a 3-page form, also filled out by a septic professional. And that basically provides a new as-built so that we can see where your system is in relation to the building that you're trying to get signed off on, so that if you do need to move the system, you can start down that process. Or if you you know, if that was the location, you can always decide to move the building as well. So footprint changes, if you're adding on to the house, that would require an as-built or an ESV. And then that bedroom addition would be an increase in flow and an authorization notice. So that's kind of the process for building permits. Excuse me. And then this slide is titled COVID-19 in your system, but could really relate to kind of any, it's a good general practice, and could relate to almost any kind of illness. So chemo and other hard drugs and treatments would also kind of fall into this, you know, think about what's going into your system. Brandon was talking about like all the bacteria. So for COVID specifically and other viruses, you know, just make sure that you're using proper protective equipment. If you need to handle any part of your system, for COVID, you are home more than you were before, so you may need to pump your tank more often. You may not as well, but you may be noticing like, oh, you know, I have to clean, you know, we don't recommend using Drano because again, it gets back to that environment in your tank. But you know, if you're finding that you have more slope drains, maybe that's something to look at the septic tank. Start there rather than products. And then you may know it as other things as well, in which case, please feel free to ask questions and we can help direct you in the right direction. So also to be aware of during COVID and other times, don't flush things besides toilet paper and human waste down the toilet. I see a lot from, you know, like the sewer system or sewer providers, you know, please don't flush flushable wipes. That goes for your own personal sewer system on your property as well. And then just kind of just reiterate that your tank is an ecosystem. You know, it is not a bad thing to use bleach, but don't use too much bleach. Don't use it every day. Otherwise, you're going to start impacting your tank. And that goes for the additives that are advertised as well. So that kind of wraps up my portion of it. Anybody have questions?
All right.
I don't see any. No questions so far.
All right. Well,
I'm back.
Claire's back.
Yeah, I'm back. Heather,
Yeah.
you mentioned minor alterations, like say out of a shop or barn hooking into a system. What is a ballpark figure for permitting for that and the length of time?
So a minor repair and a minor alteration, I believe are about $465 is the county permit fee. And we usually get those, we can issue those usually within two or 3 days.
Okay.
The new construction permits and other construction permits are more like 2 to 3 weeks. Just
Yeah,
because
you
it's a
mean
longer review time.
Yeah, like I was talking about, somebody would decide they have a pole barn and they want to put a toilet in there and add another, you know, like a tank or something like that. Is that considered a small alteration?
So if they're adding a tank to if they're adding a second tank to a system, yes.
Yes.
Like if you have your house, your primary house, and then you have a shop, and that shop is personal use, or a barn, and you just don't want to have to walk across your property, you can put a bathroom and a tank, and that would be a minor alteration.
Okay, that's what I was asking. Thank you.
Yep. Yeah, you're welcome.
Oh, no, I guess not.
All right. Well, let me share my screen again. So we're gonna conclude the workshop talking about some of, let's see, if I can presenter mode here, about some of the funding assistance that's available to people who have septic systems. And so I'm going to start off talking about some of the financial assistance that the water providers offer. We currently offer 2 different programs. The first is a $200 rebate for septic system inspections. So just like changing the oil in your car on a somewhat regular basis, we are encouraging people to inspect their systems, to understand where their system is, how it's functioning, so that they can actually head off repairs and bigger problems before they start seeing failures. The other program we offer is a septic system cost share repair program. So I have the ability to reimburse up to 50% of the costs, up to $1,000. And to be honest, in the last couple of years, most of the applications I see for the repair cost share program are people that are having to replace their tanks. And tanks are expensive, can run anywhere from $5,000 to $7,000. So I'm able to reimburse you up to $1,000 for that. So a couple of the eligibility requirements for my program. First, you have to live in the watershed upriver from our drinking water intakes. So if you look at this map here, pretty much any of these colored polygons, if you lived anywhere in there, you are eligible. That is primarily because this program is funded by water providers and water rates. So we are providing tools and assistance to people who are upstream from us to help keep our drinking water source cleaner. The other eligibility requirement is that whether you are interested in the septic system inspection, or if you are having repair done, I need to be able to find your contractor on the Oregon Septic Smart Inspectors list. I don't care who it is, as long as I can find them on that list. And then if you are doing the inspection, you need to use this form here, which is a DEQ's evaluation form. And the reason for this is it is supporting not only the state program, and this inspection form is quite long, but it also provides you as a homeowner some really good information. So we think it is worth the trouble to do this more extended inspection and evaluation of your system. The other program I want to mention briefly is the CRAFT 3 Clean Water Loan Program. CRAFT 3 has been working with both Oregon and Washington to provide people with loans for septic system repairs. The state of Oregon and DEQ help support this program. I believe the funding in this most recent legislature has extended that. So this is something, if you're looking for help, is another potential avenue. And then I think the next is I'm gonna have a stop sharing screen here so Lisa can pull up Ian's presentation, and Ian is gonna talk about the Soil and Conservation District's low interest loan program.
Okay.
Thank you. So actually, the CRAFT 3 program in Oregon is currently suspended because of they don't have the funding mechanism right now. They're in Washington, but they're hoping, I think they're hoping to begin able to start that program again. But that's kind of a recent piece of news. So
great, thanks.
Hopefully that'll get going again, because it was a great program. It has a lot of possibilities for folks. My name's Ian Rains. I'm with the Clackamas Soil and Water Conservation District, and I manage a septic system repair loan program, the residential septic system repair and replacement loan program. And I'm gonna describe how that program works, a little bit about the eligibility and just how that program works. Lisa, please, is gonna click the signs. Here's an example of a septic system that was installed with loan funds from the Conservation District on a private residential property. This landowner had a small area. They had a failed system that was going to require a new drain field and tank and everything. They basically had to replace the system, and they didn't have enough room for a standard drain field. But what they were able to get, though, using our loan funds, was an advanced treatment technology, or ATT system. Has 2 tanks, it looks like, and it can get by with a lot smaller drain field. So they were able to fit that into that yard without a problem within the boundary. Next, please. So why did the Clackamas Soil and Water Conservation District set up a loan program? We want to serve the public. We want to improve water quality and health conditions, help homeowners invest in conservation. Having available money to a homeowner helps the project get done more quickly and get started sooner, potentially, because they otherwise wouldn't have the funds to do it, and both the public and the homeowners benefit. Yes, next, please. So benefits are in our loan program, we customize the loans for every individual homeowner. So you apply for the loan and we talk about your needs and what's wrong with your system and whether it needs a repair and a bunch of stuff. But each loan is an individualized loan. Currently it's 0% interest. They've always been low interest, but currently they're 0% interest. It's a pretty simple process. We're friendly people, it's developed for you as the homeowner. And as a conservation district, our focus is on the water quality as the investment. We're not so much worried about what your income is and your credit scores and stuff as what's the pollution issue? Is there a water quality benefit? And we want to help you invest in your property. Next, please. Our loans are made to homeowners. They're not made to, like if you're a renter, we would make the loan to the landowner, not to the renter. So you would actually be the landowner that would be applying for and receiving the loan. It's not a line of credit where we say, okay, we're going to give you a $25,000 loan, so you can draw down on that. We would potentially make a loan, but we are paying the contractor directly. We've developed a list of pre-qualified septic system repair and installation contractors. So kind of a vetted list that gives us some confidence that the contractors, they're all DEQ licensed contractors, will do a good job for you. And we have kind of a relationship that we build with the contractors that join that list, so that they know, we kind of know what the process is that each other uses, and they know that they can rely on us to be able to pay them like a 50% down. And then once the project is completed and passes the county inspection, we'll pay the rest of it. Because we need to make sure that they're doing the job properly and that according to county repair requirements and inspection and all that kind of thing. So the homeowner, they would have to pay for the site evaluation if that's required. But a lot of times the cost of the permits and the materials and the the contractor's labor and even the first couple of years of maintenance may be covered under that loan potentially. The homeowner does have to repay all the costs that we pay out up to the amount of the loan. And I'll mention here that the Conservation District is able to do this program because we actually have a loan from Oregon DEQ. It's a Clean Water State Revolving Fund loan that we applied for 3 or 4 years ago. We started this program about 3 years ago. And so we will make loans to homeowners and pay the contractors, and then DEQ reimburses us, and then we have to pay back DEQ. So it's a great situation where the district doesn't have to put out all that money and wait forever for reimbursement either. But it's very important that the homeowners be in a position to promise to repay the loan. Next. So the lending limits, currently we can go up to $30,000 on a septic system repair or replacement loan. We've just increased it to 30,000 because some of the projects that have come along have been more than our earlier cap of 25,000. So I mean, we've had loans as low as $6,800 and loans as high as $25,000. Our district manager has approval authority to approve and sign a loan agreement up to 25,000. If it needs to go over that, we could talk to the board about approval for that, but that's part of our process. The first steps would be to contact us, the Conservation District, to discuss what your needs are. What do you think is wrong with your system? How do you know? Who have you had out there to look at it? What's your financial situation as far as how can you afford part of the cost? Do you have other sources of funding? How much is this project going to cost as far as the permits and the repair work? We have a loan application available from our website that'll give us some of that information. You go ahead and see what the next slide says. So we try to get a picture of what's going on. And a lot of times the county is involved in that. If there's, say, for example, a site visit, a site evaluation that the county does to see, for example, if you have another location on your property that would be suitable for a drain field. If, for example, you need a new drain field, it has to go somewhere. The kind of information that comes from the site evaluation, the information that comes from more than one contractor to give us a picture of what is going on and what the cost would potentially be, helps us figure out how much of a loan we can make. Currently it's 0% interest. We negotiate the timeline with you up to 10 years so far as how long we've made a loan. So like if somebody got a $25,000 loan and 10 years to repay it, they'd be paying us monthly payments of $208 a month. So we try to make the loan payments affordable to the homeowner within the limits that we've got in our program. And occasionally a person is in a situation where they just don't have any money and the ability to repay the loan at all. They're just financially very disadvantaged, but they've got a pollution system, or situation, and a failed septic system. We may be able to grant a hardship deferral of payments so that you really don't have to make payments now during the course of the next several years. But when you sell the property or the property changes ownership, or you refinance the property, any landowner would be at that time having to repay the loan. So sometimes there's a hardship deferral that can come into play for somebody who can't afford payments. Next, please. But we do have to secure the loan. So part of that is that all of the owners of the property sign the loan agreement and the lien document that we place a lien on the property on the title. There's a promissory note. We'll do a UCC fixture filing with the state of Oregon, which is kind of just a formality. It doesn't have a lot of enforcement at all, but it's kind of a way of recording that, you know, when you sell the property, you've got a lien on it, just like your mortgage or just like an easement or any other thing. There's a condition on the title that we place on there until you've paid the loan off. Next. So there's my name and my phone number and email address. If you go to, you could even just Google Clackamas SWCD. You'll see there's a spot to go to our website. Then you go up at the top bar. It has programs. You can list programs and go straight down to septic system repair loan program. You can get all the information about eligibility and the loan application and what the process is and how it works with the contractors. Basically, you need that for eligibility. I'll just real quick. The septic system must be located within the boundaries of Clackamas County. It must be an existing residential septic system that's in a state of failure or failing and requires repair or replacement. So it's not like you're going to add a bedroom and it's a properly functioning system. That would not qualify. You're going to build a new building and you're going to install a septic system straight out first time. No, that it has to be an existing system that's in a state of failure that requires a repair permit, like Heather was talking about, a major or minor repair permit in order for that system to be able to function properly. It's not a plumbing issue like your lines have to be cleaned out, or a maintenance issue like whatever. It's got to be an actual repair. You also would agree to use one of the contractors on our list, because we've vetted this list of contractors and they've gone to the trouble to apply. We've checked their references, we've checked their qualifications. We have a pretty good feeling that they're not some fly-by-night contractor that's gonna take your money and dig a big hole and never come home, never come back. These are reputable folks, and they all are all DEQ licensed as well. All of the landowners on the property sign the agreement and the lien and stuff, so that everybody who has an ownership stake in the property is aware of what's going on. You know, you may be the person living in the home and you're the borrower, and not everybody is listed as a borrower on the loan necessarily, but they need to be made aware of it, because if you default, they're going to be kind of on the hook for it. It's only fair to make sure that landowners know about that. And then you agree to repay the loan and to maintain the septic system following the manufacturer's or the contractor's recommendations for the life of the system. So it's a great program. We've so far made 14 loans, and I've got 3 more in the hopper. We've put out close, and you add those loans together, it'll be close to $250,000 that the district has made in the way of loans to 14. Will be 15 homeowners in the last 3 years. So I'll be happy to answer any questions, and you can always check our website. Thanks.
Great. Well, we're just a few minutes ahead of schedule, so I am going to share my screen one last time. So here is the contact information for all of our speakers tonight. We do have a couple minutes, so if anyone has any questions for any of us, please raise your hand or unmute yourself and go ahead and ask those questions. Otherwise, everyone's contact information and email addresses are here. If you have specific questions for any of us, you will be able to follow up with anyone. We are recording this, so we will have a link to this presentation online. You will find it as well as all of the resources, all of our presenters' presentations on the CRWP website at that link at the top of this slide. So all of that should be up there within the next week. So
Kim, can you make the screen bigger or show it as a
yes, sorry,
just a little small?
There we go.
Thanks.
So
I don't see any questions. This is gone. Anybody have a question? I think you guys did such a good job. You answered everyone's questions tonight.
All right. Well, thank you for being here with us tonight. I appreciate everyone's participation and all of our speakers. Thank you very much for taking time out of your evening to be here and providing this information. We really appreciate it. And for those of you who have septic systems, hopefully you got some really good information out of tonight. So with that, I think we are done. So thank you and have a good evening, everyone.
Thank you. Thanks for those presentations, guys. I was very impressed and learned a lot from you guys. Thanks.
Thanks. Good night.